right, should be live according to YouTube. Good evening, everyone. Welcome to the stream tonight. I'm just going to take this one off again because I don't need that. Just checking if the audio was coming through. That should all be good. Hi Mary, how you going? Hi Patrick, nice of you guys to join. Well, we had Augment comment something a little while ago. I don't know who else we have in the stream. Yeah, we will see, we will see. I finally got my green screen up, so no more fuzzy things with the fake green screen thing. We're going to give it a few more minutes for people to walk in before we start looking at our little space game that we're working on. Alrighty. Chat's still pretty quiet tonight. Let's actually make sure that Twitter is aware of us being live as well. Yeah. Let's see. Copy. There we go. All right, let's switch to our desktop. All right, so I've done a few little things since my last stream, not a whole lot. For those of you who have been watching me on Twitter, you would have seen a couple of screenshots and small videos. So I'll just quickly go through the changes that I have done, starting with my, where are you? With the interior of our little ship. So we now see our selected target actually inside of the editor, so that was already working inside of the game the last time that we tried it, but I've now got a preview inside of our ship so that we can position it more easily and make sure that it's in the right spot. That is also now a subscene, so everything's nicely self-contained. Not much to see in here because there's nothing selected in the subscene. It's only in the ship that we can see it. So that was the first thing that I added. The other thing that I've added is this little radar display, where, you know, as far as our radar is concerned, our ship is in the middle, and we then see all the targets that are in range. I have increased the range of our radar to about 2 kilometers right now. Oops. While the globe is currently only showing everything that's closer than 1 kilometer to us. And I plan to make that a zoom setting eventually so that we can switch between, you know, I just want to see what ships are close to us and which ones are further away. We'll also see in a minute when we run our game that we've got some color coding going on. So our friendly ships around us are all nicely green, our enemy ships are all nicely red, and the ship that we've got selected is white. The other thing that's very important here, which is very common with these sort of radar displays, is that we've got this little stack on all the ships that we see around us. That gives us an indication of how high or low they are in comparison to where we are. So that is all automatically tracked. I'll have a quick look at the code behind this. So again, it is a subscene, so it's all nicely self-contained. And when we look at the code here, which I'll blow up for a minute, we see that there's a function called update targets, and that gets our list of targets that we've found with our collision shape. The whole, hold on. That's annoying. So when we look at the radar area that we made with the collision shape, everything that's inside of that is all tracked automatically. And in the script, we're actually passing that onto our radar screen. And all we're doing here is looping through every target in that list, checking if we already have an object in our radar to actually display it. So we're creating, I keep forgetting that I need to click there. We're creating a subscene for every one of these target objects in here. We can see that we've got 6 by default, but they change depending on how many targets we have in range. So we add one if we need one, we reposition them if we already have them. So the repositioning is simply taking the global position of our target, transforming it to local coordinates based on our position of our ship. Then checking whether it is further away than our current radar range. If so, we're going to limit it to the outer shell of our radar. So anything that's beyond our 1,000 meter or 1 kilometer range is just going to be shown at the outside instead of it suddenly floating in the middle of our ship. And then finally, we simply place it based on the radius of our little radar inside of our ship divided by the total range, and that nicely contains it within our little sphere. Finally, I'm setting the color depending on whether it's a selected target, in which case I'm giving it the selected color, whether it's in our group enemies, so that we know that it's an enemy target, we set the enemy color, and in all other cases, we set the friendly color. Yeah, I'll demo the radar in game in a minute so you can see how it works, but basically it's always oriented depending on the orientation of your ship. So you'll see that when we turn or when we roll, the targets all roll around our ship, as you would expect. The final step that I'm doing here is simply removing any targets that are no longer in range from our display. So that's, you know, if I was showing 6 and now there's only 3 in range, then I'm removing the last 3. So that's basically the loop that runs every frame, every time we update our display. The other things here and you'll see that all the way at the top of our script, I've created this as a tool script, and I've done the same thing with our selected target. So that's showing our little ship in the corner. I've created that as a tool script, and that means that there's a combination of logic that will run inside when we're running our game, but also part of the logic runs while we're in the editor, and that allows us to show everything in here and make it basically do something. Again, doesn't add anything to the game that we create. It's something for us as a developer to get some visual feedback as we adjust things and change things around. And especially seeing that this ship is just a placeholder ship right now, we are creating all these displays as hologram displays. We have normal displays in the ship. Eventually we'll design a ship that is actually designed around these holographic displays, and we can move them around and place them where we actually want to place them. Having them draw in the editor just means that we have that immediate visual representation. So that is everything that I've done, continuing onwards on the logic that we were writing in the last stream. Hi, Master Ox. Thank you for that. Glad you're enjoying it so far. Completely new, something that I did, I think on Tuesday or Wednesday, just because I was experimenting with it, is I created these nice little particle effects to create engines for our craft. So we've got them on our friendlies. I put some on the big ship, so that's got some big thrusters going right now. And then somewhere around here are enemy ships. So they're red. So just to give a little bit of a different color, again, to more easily identify who are the enemies, who are the friendlies. The friendlies right now have blue exhausts. The enemies have red exhausts. Might change it later on. It's just something that I started with. And when we look at one of these guys, you can see that we have 4 engines, so 4 little trails here. And again, I did exactly the same thing as with the with the screens. I created a scene that has the particle effect, and then created a script which allows me to change everything, which then allows me to change it in the editor itself. So here I could say, well, I want to bring the thrust back. You can see that for that engine, we now have a very low flame. And if I push it up, we'll see that that thing becomes a pretty long frame. Now, on purpose, I have left the particle count relatively low, so we do see this little sort of flickering effect in there, which kind of gives it an idea of a bit of a pulse engine. We could up the particle count quite a bit if we wanted to make it a much more stable effect, but for now, I thought that was kind of nice. There's a size for this thing, so that's how we made the engines on the big carrier much bigger. And then there's a color ramp which does the color changes. So if I change that to say blue, you can see that the exhaust goes from blue to red, and then finally to transparent. Now, I started off making that or using the transparency, but because of the way that we add the particles in, it could have just as well just been fading to a black color. No worries, Master Ox. Hopefully you can join next week. Augment. This is currently for just desktop. I am using the Glass 2 renderer, so I might at some point see if I can get this to run efficiently on, say, a Quest. Currently, Godot does not do Google Daydream. You could use the plugin for Oculus Mobile for the Gear VR. Although I wouldn't really recommend using the Gear VR. It doesn't really have enough power to do this sort of stuff. Plus that Oculus has deprecated, they've deprecated the Gear VR a couple of months, probably last year ago. And obviously they've now even gone to the extent that they're deprecating the Go. So basically, you can't, you can use it for yourself, but you can't deploy to their store anymore. So those are pretty dead products as far as that is concerned. So it's a bit of a shame because there's still a lot of people who are building stuff for it. But seeing how low end some of those devices are, Godot is kind of moving beyond that, I think. Then again, with the Glass 2, if you keep it simple, you could do a lot with it. The other one thing that is noticeable here right now is that while I changed these properties, it was only changing for the one engine. But now that I have, that's a bug in the editor. Now that I've changed the color ramp, you'll see that those change for all 4 engines, and I should be able to undo these changes, hopefully. Nope. I think I just made those permanent, so I'm going to not save my changes there. So the undo on that doesn't work very well. That's a bit of a shame. Let's remember that. Hold on. Let me just close everything off because sometimes we end up saving things that we're not supposed to save. And I also need to change the color back to red. There we go. So as long as you don't save your scenes, the problem that we have here is that the resource that I was editing is a resource that is shared by all the engines. So while these are just properties of this instance, the color ramp is a separate object that is being reused amongst all of these. So if I wanted to just change the one engine, I would have to make sure that I make that unique. And now I should be able to change just the one engine to a different color. Now, the problem that I have had why it wasn't opening properly is because it's still loaded in this one. So if we go over here, this time it nicely undid it. So that's kind of cool. So this time we got lucky. Sometimes, because it is the same resource shared amongst all the different scenes, it tends to remember it in memory. I guess because I didn't bring that back into the starting scene. I didn't reload the starting scene. That still was showing our yellow engine. Anyway, that's our particle thing itself. So behind that is just a simple CPU particles object. I'm using the CPU particles here instead of the GPU particles, the accelerated particles engine, because the accelerated particles only work in the OpenGL 3 driver, not in the OpenGL ES2 driver. But for what we're doing here, we're only animating about 10 particles. The CPU is more than capable. The GPU version of the particle engine becomes really interesting if you're rendering thousands and thousands of particles. But for something like this, about 10 particles is more than enough. Hello, Madara Z, sorry. Why are you saying wait for 4.0? The particle system in 3.0 is bloody great. If you go back about 2 years in my history of YouTube videos, you'll see that I'm using the GPU particle system to animate about 1 million grass particles. It's really, really cool. Plus that is shader driven. So while the CPU particles that we're using in the GLES 2 driver is fairly basic, you can shoot the particles out of your emitter, and you've got some control over the speed, acceleration, that sort of thing. But that's about it. It does one set of logic, and the particles behave in one given way, depending on all the inputs that you have here. When you look at the GPU particles, which is, just if we search for particles here, if you use the normal particles engine, you can build just about anything. It's quite impressive what you can do with it. And it's all running on the GPU, so all the particle animation is on the GPU, and you can do some really cool things. So, like I said, I did, rendering over 1 million grass particles. There's another YouTuber who did a particle-based asteroid field where he was able to push the particles around with like a collision shape that he implemented in the particle shader itself. That was really, really cool. So it's a good system. You can do some really funky things with it. Anyway, back to this one, just to give a very quick overview. I'm thinking about doing a separate video at some point in time about the particle system and just explaining how you build something. We might get to building another particle system later tonight if we don't run out of time, because I need one for when we hit our targets. But in a nutshell, obviously emitting just says that we're emitting 10 particles. I've left the time pretty much default. Lifetime is default, I think 1 second. That's just how long the particles stay alive. You see that the animation is now slightly slower. Why is that not letting me zoom in and out? There we go. But the trail is now longer because each particle lives a little longer. This just means that the particles live only for half a second, and then it gets re-emitted, and it's emitted over and over and over again. One shot would just mean that all the particles just get shot in one go and then stop. So if we do that, then it should stop after emitting all 10 particles. But obviously we don't want that for our engine. Pre-process lets us process a number of particle frames before the first render, so to get your initial setup done. You can create speed scale to make things go faster, which we definitely do not want to use. Explosiveness is something that we might use once we start doing explosions. That has to do with the spread, with the speed at which the particles are emitted. I think if you put explosiveness at the top, everything is emitted all at once. And right now it's just they're evenly distributed. I think the randomness and makes some randomness in that explosiveness, so that you get some fluctuation in the speed of which the particles are emitted. Lifetime random, same thing for how the lifetime of a single particle. Then instead of them all living for half a second, you can have some fluctuation in there. Frames per second is how fast the particles are animated. Right now it's at 0, so it stays at our frame rate, which is perfect for what we want to do. I'm not sure what the fractional delta that is used for. I wonder why you would want to have that option, actually. I'm surprised, I've never used that. So drawing, so we got the local coordinates. That means that as we move this around, the particles stay in relation to our origin point. While if we turn that off, the particles are emitted in in the spot where they are emitted and move from there. So as we move our emitter around, it doesn't have an effect on the particles already emitted. I definitely want to turn that on because as our ships are going to be moving at quite high speeds, if we would leave the particles global, they'd just be all over the place. The whole effect would be gone, basically. So that's not something we're doing. Links work here. I don't know, to be honest. I think YouTube doesn't like you linking off page. I think that's indeed something that YouTube has turned off. We've had problems with that before when we tried to share a few things. So I'm not quite sure. So anyway, just to continue with what we're doing here. So emission shape, we have a point emission shape, which means that all the particles are emitted from a single location, but you could change it to a box shape or a sphere shape, and then you get a random emitter within that given area. For this, we want it all emitted from our engine. We don't do anything with the flags here. We want to specify a direction in which we're emitting all the particles. So we're emitting in -z, which is out the back for us. Spread, that is the spread within which we do. So if we up that, so let's say that we set a 10-degree spread, you can see that it fluctuates in which angle they are being emitted. Now with an engine, we want them straight out the back, so we want a very small spread there to really get that pointy exhaust. I've disabled the gravity. There's no gravity in space, so we don't have any effect of gravity in our particles. This is where the importance lies, is we have our velocity. That's the speed at which the particles get ejected out of our engine. And that is actually linked up to the velocity times the flame size. So these two properties, when you change that, are actually changing our velocity in our particle system here. I've got a small little random factor in there, so they're not all emitted at the same speed. There's a slight bit of fluctuation there. Again, just to give that sort of ramjet sort of effect, as if it's like a pulse engine. Angular velocity is how fast the particles rotate, which hardly is visible in this case. I am rotating them again just to get a little bit of fluctuation in there, but it's for this, the effect is hardly noticeable. So yeah, so what else is important here? We're not doing anything with acceleration. They're all just going out at the same speed, but this is important. So here we have how our particles are scaled, and we can see that our scale amount is again coupled to that property that we defined on our script. So the higher we set that, the higher our base scale is. But after that, we also apply a scale ramp. So this fluctuates the size of the particles over time. So they're at 1, which is just the scale amount itself. So if I split this to 2 times 1, 2, that's the starting scale when the particle is emitted. And then by the time that the particle reaches its end of life, it has shrunk to about 60% of its size, and that's to give that sort of that sort of pointy shape to the exhaust. All the other things is just how this, because this is actually baked to a set of values. So with the resolution 100, we have 100 steps between the start of the lifetime until the end of the lifetime, which, now, seeing that we're rendering at 90 frames per second and the lifetime is about half a second, that is more than we need. I could put that down to 45 and it would still be perfect. All right. And then the last bit is our gradient. So that is directly coupled to the export gradient here. So that's the same thing. And that's the thing that we already looked at, where we are changing the color of our particle for its lifetime. So we start, when the particle is emitted, we start with yellow. We then go to red, and then we go to black to sort of fade out the particle. And the last thing that is important here, which somehow I missed. Where are you hiding? Geometry, no. Where is the actual particle that we are emitting? Oh, over here. So we're emitting a mesh. So in this case, does it say that in the pop-up? I'm not quite sure. Let's go and actually open up our mesh here. So we are emitting a quad mesh, which is just a square, which has quite a big size to start with, but it's scaled, and it has a material assigned to it. And this is somewhat where the magic happens. First of all, where is my albedo? There we go. So first of all, we've got this texture assigned to it, which is just a texture that goes from white to transparent the further out in the texture we go. But there's a small bit of noise in there as well, just to make it not super even. And that is actually then multiplied by the color that we get. So our vertex color is the color that we're getting from our gradient, which changes over our lifetime of our particle. So we need to take that, use as albedo tick box. That means that that is the color that we're going to be using. It's basically going to ignore the color that we set here. So our yellow is then multiplied by the color there. So that's the first thing that's important. The other thing that is important is that we turn on transparent, or else, and I think actually that doesn't matter. No, that doesn't matter in this, because the base color of our image is white. So without a transparent, we would just have a square blob. With that, we actually have our fade out working. I've also set it unshaded. Obviously, our lighting does not affect our engine. Our engine is its own light source. And then the last thing, which is important, which is in parameters, is that we've turned this into a particle billboard. That is what makes it that we always see our flame regardless of the direction that we're looking at. If we turn that off, just for fun, we can see that we can only see the particles from one direction. Obviously, that's not something that we want. We want to always be looking directly at the particle. And the other thing is this blend mode, which by default is mix. Not too bad actually in this case, but we make that additive, and that means that especially when you start looking dead on, when all the particles overlap, you get that nice glow in the middle, because all those particles stack on top of each other and they all get added to each other. Hi, sounds weird. Hi, SSLX. How are you guys going? All right. So that is how we're using the particle system here to create that flame effect. So those are all the things that I've added since my last stream. So let's go and have a quick test flight and see if everything is working fine. Get my trusty little headset. All right. So here we can see our radar screen, but we don't see our selected crafts yet because we haven't selected anything yet. So let's just get out of here. Boom. And select our little carrier. So we see our carrier now hovering there. And in our radar, we now see that our carrier is in white, our radar dot, while we have a couple more green dots around us. So if we cycle through the targets, that's our friendly ship that's actually inside of our carrier. If I go a little bit closer, you should see the selection box inside there. And the other guys are outside over here. So when I select that guy, I can see it. You can see the particle effect in action. And you can see that our radar is nicely rotating around it. And we also see our shadows being cast on us whenever a asteroid gets in front of the sun. So we're slowly getting away from our carrier. And there we go, we got some enemies, and we can see that the enemies are shown in red. Also, now that we are out of range of our carrier, we see that we no longer have a target selected. So let's select one of our enemy ships. There we go. And we can go and see them. So we can select each one of them. Cycle through. There we go. So, and again, we see them in our preview there. We see which ship we've got selected. And we see the same in our radar. And again, if I roll the ship, we can see that our targets are nicely flowing around our radar screen. So I should be able to find them again. There we go. All right. Cool. I think the next thing to do is let's see if we can fire at these guys. Now, obviously, they're not moving. We haven't done anything with movement yet, and that is for probably a week or two from now. But let's first see if we can get something to. Oh, right. So we're getting another particle system. Okay. Well, if John wants to build another particle system, he's got a lot of experience building the previous one, so all good on him. I guess he has to, because with the Vulcan renderer, we can't use the OpenGL implementation of the GPU particle system. So there's bound to be a new one as a result. Whether it is going to add a lot of functionality, I don't know. I haven't looked into it. Particle system has done more than enough for what I want to do, so I'm happy with it. But if he comes up with new cool things to do in the particle system, I'm all for it. And the more you can do with it, the cooler it is. But as far as I'm concerned, what the particle system can do in Godot 3 is already pretty amazing. All right, so we need to start adding some guns to our ship. Now, one of the things that is important when we're looking at guns is that once we start introducing multiple ship types, we could end up with multiple guns. So we want to make the guns and the missiles and every other ordnance that we're going to add into our game, we want to make them as modular as we can. So when we're looking at our plane, we have our plane base class, which is just a collection of all the logic that we share between all the different planes that we can fly in. But there's no point in adding the weapon system here. Because, like I said, every ship is different. Every ship will have a different number of hard points. So this is one thing that we're not going to add in this place. Instead, we're going to start adding the gun system to our actual ship, but creating them as subscenes that are easily reusable, so that we can add 1, 2, 3, 4, how many weapons we want, and then configure on the weapons themselves the way that we want these weapons to be selectable. Now, I've already in our input map created a mapping for our primary fire, which we're going to use for our projectile weapons or our laser guns or whatever we have added to our ship, and a secondary fire which we'll be using for our missiles. Although possibly that's something that eventually will make configurable for the user, that they can choose which weapon is fired with primary fire and which weapon is fired with secondary fire. Hi, Joseph. Yeah, I'm glad you enjoyed that that explanation. Soundbeard, thank you. Gerson, welcome. Yeah, Vulcan powered particles. We're gonna have to have them because we won't have OpenGL powered particles anymore. And you know, basically the current particle system, the accelerated ones, is already using computer shaders, just written in OpenGL instead of written in. Oh, I actually don't know, because Vulcan is, I think, still using GSLS as a possible shader language that's then compiled to Vulcan's internal instruction set. So, as far as I'm aware, from what I've been working on with, what's his name? God, I forgot his name now. I'm so terrible with names. Well, when we were working on the sky shaders for Godot 4, which is pretty cool, and I built the base for that, and then one of our friends implemented the rest of that. I hate it when I can't remember someone's name. It's horrible. I apologize for that. But those shaders are all using GLSL as well. So that's still the core. Even in Vulcan, that's still the core of the shaders. It's just what you can do with them is it's quite a lot more advanced. So yeah. So when we look at our fires, we'll probably eventually make it selectable. Also, if you have multiple weapons, you don't want to fire them all at the same time. You might want to select them in groups and things like that. That is a worry for later. Right now, I just want to add guns that fire on the primary fires and missiles that fire on the secondary fire, and not really worry about the rest of the weapon selection logic. That's something that we'll add in the near future. So changes will be coming when we get there. I do want to create a modular system. I don't want to create a base implementation that we are going to do different implementations for, so that again it becomes easier to swap weapons around without having to duplicate a whole bunch of code. We'll see where we get with that. Tonight I'm just gonna wing it. Start with just the basic logic, and then probably during the week I'll clean it up and make it a bit better. So we're going to start with just normal, maybe laser bolts or just particles. Well, not particles in this case. This is something that we shoot out. Yes, John, absolutely so. There will always still be people using the Glass 2 driver. The Glass 2 driver is not going. It's temporarily disabled in Godot 4 because we have to rework it. But the Glass 2 driver will be coming back for the very simple reason that we still target older phones. For older, there's a lot of people still using older Android phones. And for the 2D games and the small 3D games that people make in Godot for those purposes, still need the Glass 2 driver, so that's not going anywhere. But obviously for everything that supports Vulcan, it makes more sense to use the Vulcan implementation. I think the current plan is to have the current Vulcan renderer that John made as the high-end renderer, and then have a toned-down version if the need is there for lower-end hardware that does support Vulcan. Because again, the same problem as we have between Glass 3 and Glass 2, when you look at all the GI probe logic and stuff like that, it does require you to have a faster GPU than some people might want to target. It's also one of the reasons why I'm doing this project on Glass 2, even though there are a couple of nice things in the Glass 3 shader that I could use here that would make some things look a little bit better. I really want to be able to deploy this on hardware. VR has got a higher bar as far as performance is concerned, so I really want to be able to target the lower end machines to still be able to run this game. I'm probably going to need to do more before that's ready. We already have identified the problem here that the carrier drops the frame rate when we're inside the carrier, so that's something that I'll change in due time. But there's like some of the planes we might see if they're too high poly count, or we'll see. Once we the nice thing about this type of game, when you look at a space environment, because you're in a vacuum, you're in the middle of nowhere. There's some the asteroids is probably the most expensive thing to draw right now. You're not on a terrain with lots of buildings around or lots of vegetation or something like that. So the chances of really getting into performance issues are very low. unless I'm being stupid and putting models in here with tens of thousands or hundreds of thousands of polygons, then I might be asking for performance issues. But yeah, I am targeting that this should be able to work on relatively low spec VR ready PCs. Well, we might have to do some things where you can turn some things down, depending on the hardware. Soundbird. Well, I announced my stream on my Twitter mostly. So anybody who wants to, make some noise and bring some more people in, I'm more than happy to have more people in the stream. But yeah, I could probably do a little bit more about marketing. I'm not a very good. I'm not very good at marketing myself. Also, keep in mind, I'm in Australia, so I am streaming right now, 10 p.m. in Australia. A lot of people in the US are still asleep. I'm not quite sure what time it is in Europe. So the timing of the stream might not be ideal. So seeing that most of the developers, or Godot developers, are in either Europe or in the States, so that will always be a problem. Where were we? We were trying to start with creating some sort of thing that we can shoot. So I'm not really going to be too worried about what it are they laser balls that we shoot, or are they something else? Eventually we'll probably have a rail gun and a laser gun and some other things. We're not going to worry too much about that. So we're going to start with spatial as always. We're just going to call it gun, and we're going to move that to where we want our particles to be. Well, I keep calling them particles. They're actually not particles in the sense of GPU particles, or they are just objects that we shoot out, bullets that we shoot out. And I'm just going to put that somewhere over here. So this, I think, are the gun emplacements on this ship. I should have probably. That's okay. I should have saved this first. Where am I going to place this? I'm actually going to go and place that in here. I'm just going to call it weapons. I'm actually going to call this weapon because eventually this might also be the base for our missiles. So this is just to trick it, just to make sure that I've got a different one, because I should have created this before positioning it, because I want it to be in the center here, so that when we add it in, it always is added to the center. So I can now move that back a bit. If I hadn't done that initial move when I zeroed it out in the subscene, it would have translated back to the start, and I didn't want that. So that is just going to be the place where we're going to emit our gun particles. So we're going to go and shoot it from there. All right. There we go. Now let's start implementing our weapon script. So the script on this, actually, I'm going to call that weapon here. Because again, I want to be able to use the script for my guns, my lasers, my missiles, anything that we can shoot. We want to use the same script for, and just be able to change how the thing behaves. So there we go. We got a script on this thing. Let's just get rid of that. So I should change my default there. 10 a.m. in Brazil. Well, that's a pretty good time, I would say, unless you have to go to work, because I'm assuming it's Friday morning for you guys. That's the other problem, for me it's Friday night. I'm about to start the weekend, but a lot of people are behind us in the world, so a lot of people have to go to work, which is a bit of a nuisance if you want to watch your favorite streamer. Not sure if I'm anybody's favorite streamer, but we can hope. All right. One thing that I did want to mention about this, which you'll see me do a lot with these type of things, I try to always start these sort of scenes with a spatial node instead of whatever the node is that we're implementing. So in this case, there isn't actually anything directly on this node, but let's say when we look at our radar screen or our selected target scene, we could have used the mesh instance as the root node there. I like using the spatial because that means that none of the properties that we don't want the user to see, they won't be there. They're hidden within the scene tree. And we just expose the things that we want them to have control over. So one thing that we want to do here is start with a packed scene. And I'm going to call that projectile. So we're going to allow the us as a designer who uses this weapon subscene to then set which projectile we're shooting. So that's going to be either our bullet, or it's going to be our laser bolt, or it's going to be our missile, depending on what sort of weapon we are implementing here. That also means that the behavior of the object that we're going to instantiate here is going to be contained within that object. And we can make that as simple and as complex as we want. So that's the first thing that we want to do. The other thing that we're going to do is, I wonder if you can actually do that as a selection. I'm just going to call that a string for now. And that's called action. And we're going to default that for now to our primary fire. And what I also want to do is export fire enabled true. So we're going to be able to turn our weapon on and off. So that's the trigger for firing this object, and that is whether we can fire or not. So we can enable or disable our weapons. We want to have a cooldown. That's probably going to be a float for our cooldown. And let's say that for this one, we're just going to default that to a 1/10 of a second. So we can only shoot our weapons once every 1/10 of a second, 10 times a second, basically, which is nice for, a gun. But obviously for our missiles, we'll probably make that lower. Which also means that we need a ammo count. And we're going to default that to 0. And that means that if it's 0, we basically have infinite ammo. So for our guns, we can shoot it as many times as we want. Maybe for a bullet-based gun, we'll eventually give it a limit. And that you have a limited amount of bullets that you carry. But for instance, for a laser, as long as you have power, you can shoot the laser. So we might have another trigger thing, when we run out of power or something like that, that we either slow down our rate of fire or disable the gun altogether. That's something for later. But for physical things that you shoot, bullets, missiles, stuff like that, we want to potentially limit the number of available items. So for rockets, we might only carry, say, 6 rockets. So you only want to be able to fire off 6 rockets. Ooh, welcome from India. 6:15. Well, that's closer to what we're here over here. 4 o'clock. Where is 4 o'clock? Waiting for the workday to be over. That sounds nice. Also, almost at weekend. Yeah, quarantine is messy. I'm lucky for now in Australia, unless you're in Victoria. Victoria is going the wrong way. New South Wales, where I am, we're getting there. Let's not get into politics, but I'm not too happy about how things are handled here in Australia. I think they have been very foolish in letting the lockdown not last long enough, and we are starting to pay the price for that. But that's my opinion. But yeah, we count ourselves lucky here in Australia. Don't want to be in America right now, and some of our friends, our Godot friends in Brazil, I've heard are in horrible conditions. So yeah, count yourself lucky if you are healthy, and I hope you all are. So. Ah, Gerson, you are in Brazil, so yes, indeed. Yeah, I've heard it's really, really scary over there. So, oh, Moscow, Russia. How cool is that? This is one of the things that Finland, yeah. This is one of the things I really love about Godot. Godot is one of the few communities and engines that really is that has a really wide following over the world. Obviously, there's Unity and Unreal developers all over the world as well. But for some reason, I think potentially because Godot is, I think John is from Argentina, if I'm not mistaken. It's there's a lot more material available in other languages than English, which I think is one of the reasons why Godot has such a following in non-English speaking countries, which is really, really cool. So yeah, glad to have such an international cast watching me. Yeah, so when we look at the weapon systems, I try and do it this way to kind of anticipate, to at least be able to implement the weapons, the different weapons that I envision so far. And hopefully I capture enough that I don't have to do major refactors when the number of weapons grow. They might, in which case I have to do a lot of rework. But you got to start somewhere, and hopefully we are going down the correct path with this. So we got our projectile set, we got our action. How do we fire? Whether our gun is enabled, our cooldown, and our ammo count. Perfect. So we obviously want a timer for our cooldown. So let's add that in. That also means that we want to have, that's an internal one, is a can fire property. So that is true as long as we can fire. The moment that we fire, we turn that to false. And then our cooldown starts, and our cooldown is going to turn that back to true. So in our ready function, actually, we are going to do a set get, set cooldown over here to make our life easier. Set cooldown, new cooldown. So we always start by setting that to itself to remember what the cooldown is that we set. So if you only specify a setter method and you don't specify a getter method, we have the default getter method. So I used to always implement the getter methods, and just a lot more typing. It's not really good. So the other thing, and I've repeated this lots of times and I can't say it enough, the first time a setter method is called is before our scene has finished loading. So the first time that this is called, our cooldown object won't exist yet. So we have to check here if our cooldown is available. And this is actually, I don't know if you guys have noticed that, but it's already cleared that out. Sometimes you see, actually like here, node not found, targets are 1. That is because when you do something like this, it does give that warning, hey, cooldown, it'll be there soon. Cooldown is not found in yet, because the first time that we call it, the cooldown isn't found yet. We can ignore that. We could just call find node. That way it won't have that bogus message in our logs. But I like this better aesthetically. So we are going to set our wait time to our cooldown. And obviously, because when this gets called the first time, we don't have our cooldown object available yet. We can't update our cooldown object yet. We're going to, we're just going to call our set cooldown with the value that we've set before. So if my cooldown is changed to, let's say, half a second, first time this is run when my scene loads, I don't have my cooldown object yet, so it just stores half a second in our cooldown variable. And then once ready gets called, which is called when the scene is fully loaded, we call it again, and that now sets our cooldown. Now, I'm doing this as a setter method, even though it would be more than enough to just set this in the ready, because generally speaking, it will never change once set. It's a, for lack of a better word, it is a constant. But who knows? At some point in time, I might decide that some weapons might have a variable cooldown. Like I said, for instance, my laser, I might want to change the cooldown higher as the energy level in my ship drops. So again, a common mechanic in these type of games is that you need to do energy management. You either direct power to your engine so you can go faster, or you direct power to your shield so that you can take more damage, or you direct energy to your weapon so that you can shoot for longer. Obviously, if I've directed my energy away from the weapons, I might want to increase the cooldown so that I shoot slower when I'm running out of power for my guns. So that is one of the reasons why I have done that, or I'm setting that like this, because that is potentially something that I might want to control externally. Don't know yet. Again, we're not that far in developing our game yet. We're just thinking ahead of that we might need to be able to do that. What's my VR set? I'm currently using a beautiful Valve Index, my pride and joy. This is my favorite headset that I have here as far as VR itself is concerned. This is what I play all my games with, and that's the one that I've set up on this laptop. I've got a Rift S over there, which I actually use more regularly when I develop games. The reason simply being that the only thing really that I dislike about this, especially because I wear glasses, is this is a very uncomfortable headset to put on and off and on and off. And obviously you see that in my stream, I'm taking this thing off 100 times during the stream. Half the times my glasses end up getting stuck in this thing. Every time that I put it up, my glasses get pressed against my face. That's the only bad thing that I can remark about the Index headset. Hint, hint, if anybody watches who works for one of the prescription lenses companies, sponsor me, because that would solve that issue. While with the Rift S, because it has the halo design, and it's a bit stuck right now. I'll knock my green screen over if I try to grab it. The Rift S is, because of its halo design, similar like a PSVR headset, it's so easy to just put on and off. So when you're developing, I actually prefer that headset, but I don't have this laptop set up for my Rift. I've got my other laptop set up for my my Rift, which I'm currently using to stream with. I also have a Quest, which I absolutely adore, but I don't feel the Quest, if you don't have the funds to buy multiple headsets, which it goes for a lot of people, the Quest is probably the best bang for your buck. It's the most wonderful device to actually play VR games with, because one of the downsides that I have with my Index and the same, well, the Rift S is actually kind of okay with that as well, but I'm limited in the space that I have here in this room. My Quest, I just walk into our living room and I push a table out of the way and I've got space to play. So I love that about the Quest. But then obviously you hook up your Quest with the link cable and you can suddenly use it as a desktop VR headset as well, which is really nice when you're developing. Even if you're developing for the Quest, one of the downsides of developing for the Quest is you have to push your game out to the Quest every time that you want to run it. So having, and this is something that's really nice about Godot when you develop for the Quest, is you can actually very easily switch your game between deploying to the Quest and just running it on the desktop like I'm doing right here. So you can develop on desktop and prepare your whole game on desktop. And as long as you keep in mind that you test regularly on your Quest to see if you don't have any performance issues, you can just switch between them. And with the link cable, you use it in desktop mode, you develop, and then when you want to actually test whether it runs properly on your Quest, through the same link cable, you push the game out to your Quest, and then you just play it on the Quest natively, and you can test whether it's working perfectly, which is a really nice workflow. Did I find the culprit from the frame rate drop? Yes, to some extent. I think I talked about that last stream, and I'll just really quickly recap on that because I don't want to get back to that too often. There are two parts to where there are issues with frame rates. One is this really big asteroid field that we have. I was using a quite high polygon model, or a set of models actually, for the asteroids, and that was really causing a toll whenever you're at a angle where you can see most of the asteroids. So what I've done is I've gone to a very low poly model for our asteroids, and when I really zoom into one, you can hardly tell. These things are still as detailed as they get. So you can see that doesn't look like a low poly model. You can't really distinguish those, but it is. This is one of Union Byte's asteroids in its lowest forms. Now I do plan to add an LOD system to this. I just wanted to build a whole bunch of other things so that when we're up close, we do see a higher poly count asteroid, and for the ones that are further away, we might even eventually go to a billboard to really, because most of the far away ones are just a couple of pixels, so they don't really need to be full meshes. So that's something for the future, but I didn't want to waste too much time with it. The other problem that we're having is this carrier itself. This is we did go to a slightly lower polygon model, but it's still an incredibly high detailed object. These are not textures. These are actually all individual objects. The same with these landing pads. They're all, there's probably about 100 polygons in each of these landing pads. So, and because this is a single mesh, the whole thing gets rendered. Even the parts that are off screen go through the whole render engine. So there's no optimization for our carrier here. So whenever we're inside the carrier, we're really stressing the GPU out because there's a lot of processing going on that it doesn't need to do. And that is because this model was just downloaded as a wavefront OBJ file and imported as that. That's not how you ideally would do something like this. If we wanted to have this carrier and we want to keep this carrier, what I would do is, well, if I had an artist build this for me, I would ask him to make different versions of the carrier. So the version that he would build initially is the full DZ version, but one where the runway is its own object, all the landing pads are their own objects. So basically we break up the carrier in smaller objects so that the engine can actually start excluding things from the rendering pipeline and really only render what is actually in view. And that should solve our frame rate when we're inside of the carrier. Then once you're outside of the carrier, like for instance, once I'm on this distance, I would actually switch to a lower level detail version of the carrier where we strip out most of that interior. We might map all the, this could just as well be one big square internally with a texture that has, the landing pads and stuff like that on there. So that all of a sudden our carrier becomes a much simpler object and it doesn't stretch the render engine out. Now, luckily, this is now a low polygon enough model that when it is not filling the whole screen, it's not really stressing out the GPU. On this laptop, this is a laptop with a 2070 RTX NVIDIA card inside of it. So this is a relatively beefy laptop. I'm pretty sure if I would run it on my 1060 over here, I would get frame rate drops again. And again, the carrier at this point in time is not optimized, not built for what we're doing here. And that is not a judgment of the guy who made it, because if I have the original file, it would, if you model this in Blender or Maya or whatever he used, it would actually be broken up in all these parts. It's that it's exported as a wavefront file, and the way that Godot imports wavefront files, it comes in as one big object, and that is just not efficient for what we want to do. Well, if we would have saved it as a GLTF file and imported as a GLTF file, it would probably already break up the whole object into smaller objects, and we wouldn't be having this problem. I don't care at this point in time for the very simple reason that I don't plan to use this carrier in the long run. I'm just using this because I found it. It's served my need. I have something to stand in. We're going to go to a very complete carrier design once we are further along with our game, where hopefully at some point in time I'll be able to afford hiring a 3D modeler to model something to my design and my specifications. So yeah, those are really the two culprits. The fact that we have very high polygon asteroids, and the way that our carrier is constructed is very inefficient for what we're doing here. It's too big a model to render all at once when we're inside of it, and it just kills. It's also what you noticed if you paid attention when we were flying out of our carrier. We were at 50 frames per second inside of our carrier. Boom, 90 the moment that we left. And even when we're looking at it from a distance, 90 frames per second, no problem whatsoever. So yeah, we're getting there. All right. So that's all sort of things. This is stream number 5, so we've had 5 Fridays to build this stuff. So we're still very much at the beginning of our journey. All right, let's get back to what we're doing here. So when we are updating our cooldown property, we are now automatically updating our cooldown timer. Now, in this case, I'm not yet making this a tool script. I'm not sure if there's ever going to be a point in turning this into a tool script, because there's no visual element to this gun until we actually shoot it, which we're never going to be doing in the editor. So I'm leaving that out, but we might put that back in. Who knows? But for now, I'm assuming that we might be making the cooldown variable at some point in time. That's why I'm adding a access method to it. For most of the other ones, we currently don't worry about it. We just make them normal export variables, and we don't need a setter method for those. So obviously, when we shoot our weapon, we will turn can fire to false. We start our cooldown, and that means that once our cooldown finishes, on its timeout, we want to make sure that we turn can fire back on. Boom. So that's as simple as it needs to be. That's all that we need to do for cooldown. Actually, I'm going to put it here. So let's go and implement that we can actually shoot. And in this case, we're going to say if we're not enabled, we exit. Oops. So we only want to check if we need to shoot if we've enabled a gun. If you can't fire, again, no point in doing something. If where is it? Projectile. If you don't have a projectile set, then we also exit. Now I could add those all together. I could string them into a single if. I kind of like writing them out like this so that we can, we can more visually see what are all the individual checks. Personal preference. It doesn't really matter performance-wise, not for something simple as this. So we now have checked: is our gun enabled? Can we fire? Do we have a projectile to actually fire? So the final thing is if input dot is in action pressed. I'm doing action pressed here, not just pressed, because I want to be able to hold my gun and keep firing. That is something that we might want to make a setting at some point in time, and saying, well, you have to click the button and let it go to fire a missile. But a gun or a laser, you can just press down on the button and it will repeatedly fire. We'll have a thought about that, but for now, that is what we do. And action. Is that how to call it? Yeah, action. So probably means that we should also check if we have a action set. So if we don't have an action set, we say also goodbye, we're going. Alrighty, so if our button is pressed, let me just take this up. Now let's go and fire our projectile, and that's pretty easy. We start with creating projectile, a new instance of our projectile scene. Alrighty, that reminds me, my age-old trick. We're making a 3D game and we're adding a 2D node. when we are adding a projectile, and some of the other tutorials that I've done and some of the other projects that I've done, I tend to create a container in my main scene to add all my spawned objects into. But it gets messy real quick. In this case, I just want to be able to add my projectiles to my scene inside of my weapon scene, so that all the projectiles that this weapon shoots are contained within the instance of my weapon scene. But if I would make that a child of my weapon, that as my weapon, as my ship moves, and therefore my weapon moves in space, all the child objects move alongside with it. Now, creating a node 2D node, because that doesn't have a 3D position, it breaks the chain. So any 3D object that we child on the 2D node gets positioned in relation to our universe's origin point. And all of a sudden we have made that remove the join between those two, which is exactly what we want. So that is the trick that I use here. So I'm going to call that projectiles. There we go. Projectiles.add child, new projectile. There we go. Okay. Then we need to adjust the position of our projectile to our weapons global transform, so that gets the global position and orientation of our weapon node, and we're going to go and fire from there. And now our projectile should get a default speed. Now there is that is something that is going to be interesting. So we need to take the speed of our craft at this point in time. How fast are we moving? And then add some speed to that based on how fast our bullet is. And that's obviously going to be different for every type of weapon. So a bullet that we fire, or a laser bolt, will be very fast going away from our ship, while a missile would be going basically the same speed as our fighter, and then accelerating away from it. So that behavior is actually something that we're going to be coding inside of the projectile itself. So I think it's time that we go and start setting up these projectiles, starting with a base scene from which we are going to extend all our other types of projectiles. So let's start with a new scene. We call that projectile. Save. Models, weapons, projectile. We're going to go and give that a scene. There we go. Or a script, I mean. So let's put that in there. And we're going to add a function here. Set initial velocity. Actually, we're going to change the type of this projectile. In this case, I actually want the projectile to always be the type of body that we base projectiles on, which is a rigid body. That just makes more sense in this case. So rigid body, we have to make sure that we extend from the right script. Base velocity vector 3, and we're going to pass for now. Okay, so our weapon script is going to tell our projectile that we've just created and just positioned at the muzzle, so to speak, of our gun, the current velocity of our ship, so that we can base our velocity of our projectile on that velocity. Now for a bullet or a laser bolt, we'll add more speed to this. But for a missile, we'll probably set that as the base speed. So this actually we're not going to implement here. We're just going to make sure that that method exists and just say this should be implemented on our extended script. Now, Godot, as far as I'm aware, does not have a concept of template classes. So I don't think there's a way to force us to implement this on on any of our extended scripts, but I still like to do this so that we know that that is something that we need to implement. All right, we don't have anything in the ready function to do right now, so we'll probably end up putting more stuff in here as we go. Whenever I have a rigid body base script that I'm going to extend, I always add our collision node to it because we are going to need that anyway. We're just not going to add a shape to it because we don't know yet. The other thing, which is probably a good idea here to do already, is set up our collision layer. So we already have a projectiles collision layer, so we're going to put that in there. And then as a mask, we got to figure out what we're going to hit. Now, we're probably going to use the same projectiles for projectiles that we shoot, that our wingman is going to be able to shoot, and that our enemies are going to shoot, because our enemies are going to be able to shoot back at some point in time as well. This is something that we may inherit or get from our weapon that is firing our projectile. For now, I am going to just set this to enemies. Seeing that we're going to be the only ones that are going to be firing these projectiles, if we would tick the player, looking at our player here, we will see that our collision shape of our player actually extends beyond our spawn point for our projectiles. So the moment that we shoot, we hit ourselves. Not something that we want to do. So that's probably going to be important once we get a little bit further, that we're probably going to set that collision mask on the weapon. And then every time that we instantiate a projectile, we're just going to copy that over. And obviously, when we shoot, we're going to shoot projectiles that can only hit our enemies. And when enemies shoot, then the friendly and player layers are going to be selected. Might actually do that right away. Why not? Seeing that actually sounds exactly what we want to do. So let's have a look at where I already implemented that, because I did somewhere. I can't remember where. Probably in our add-ons. Did I do that in this version already? No, not in that one, in this one. Functions. Pretty sure that I implemented it here. This is still the old one. Dang it. I haven't updated it yet. Because that was a fix that I only did very recently. So now I have to think, where did I implement that here? I'm also just going to go and copy that over from where I did fix that up. XR plugins. No, it's not in XR plugins. It is in where did I put that? I hate it when I've got too many folders to look through. Where are we? Assets, XR tools, add-ons, functions. Let's go open with. All right, open in an atom. I thought I installed Sublime on the same. And now, here we go. That's what I wanted to copy. Boom. 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 Weapon. Where's my weapon scripts? Weapon, 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 weapon. Here we go. So let's go and put that in here. So we are not going to worry about those. That's going to be the wrong one to default with. So let's see. No, where's my projectile here? So that's 1, 2, 4, 8. So we're going to just default that to 8. Boom. All right, and that means that we are simply going to say new projectile dot collision. We know that's going to be a rigid body. Collision mask is collision mask. All right. So now on our weapon, we can see that we have a collision mask control. Good night, Patrick. Nice of you to join. Glad you enjoyed it. So, hope to see you next week. And I'll see you Tuesday on your stream. So, I'll see you then. Have a good one. Okay, so now we have a collision mask set on our weapon, which allows us to define the collision masks of the projectiles that we end up firing. Maybe we should name that differently at some point in time, but for now I am happy with just calling that collision mask. So whenever we fire our projectile, we just set the collision mask of our projectile to the mask that we set on our weapons. Right now set to our enemy mask, so that we can only hit enemy ships. We can't hit anything else. The bullet is going to just go straight through anything else and just not hit anything. But we'll see. We might do more things with that eventually. And again, once we add weapons to the other fighters, so to our enemy fighters, and we have our enemy AI fire bullets, we'll change the mask on that to hit the player or friendlies, and automatically everything starts to just work, which is what we want. All right, so I'm not going to worry about any further logic in our script here. We're going to add more things in here, because once we start hitting things, we're going to put most of the logic in here, so that we don't have to re-implement that on every projectile that we do. But for now, that's enough. So we're now going to create a new inherited scene, and we're going to inherit from our projectile. Boom. And let's just laser beam. Why not? So we're going to start with implementing our laser beam. Alrighty. Now we need to think about it, because the other thing that I want to do, let's go and save this. Let's have a look. I'm going to look at our weapon. Let's see. Yeah, so we're going to set our global transform, and then we're going to say new projectile dots. What do we call our function? I should really close a bunch of these things. Might make it easier to find what we're looking for. Bear with me while I just close. I don't want to do close all, because then I close too many things. But let's get rid of a whole bunch of scripts that we're no longer looking at, so that we're a little bit better here. So that's our weapon script. Here's our projectile script. So set initial velocity. Boom. So we now need to calculate that velocity. So are we going to get that from our parent, or are we just going to measure that here? For now, we're just going to measure that here. Last, actually, make that an on ready var. Last position is global transform dots origin. So we're going to record where we are at our start position. And in here, we're going to say our new position is global transform dot origin. Then var velocity is new position, take away our last position. And that's going to be the velocity within one frame. Eventually we'll have to divide that by delta. And then our last position is going to become our new position. So we could go back to our parent object, which eventually will go to back to our rigid body of our plane and get the velocity from there. But we can figure it out this way. I think that's good enough. So here we're just going to say velocity, and we're going to divide that by our delta, so that we get a velocity per second. So that if our frame rate has some sort of fluctuation, we know exactly how fast we're going in our process function. And that actually also means that I'm actually going to move this to our physics process. Oops. In theory, even though it's not very likely, but in theory, if my frame rate would go above my update rate of my physics process, it would be possible that I get 2 calls to process without the physics being processed, in which case our ship would have stood still for 2 frames. Now again, it's not very likely because we are rendering at 90 frames per second and we have set our physics process as a factor of that. So I think right now we are, is that in here? Yeah, I've just set it to 1, so I'm supposed to right now run at 90 updates for the physics, but in theory it could be lower. So I want to make sure that we actually have a valid delta and that our position updates are actually solid. So that gives us a pretty accurate velocity for our object. Okie doke. So that is now communicated to that, which now means that for our laser beam, we can start putting our laser beam together. Now, I don't know how many of you guys have seen my latest weapons tutorial episode where I'm talking about projectiles and making sure that they hit things because they're traveling real fast. Obviously, we need to take care of the same here. Because yeah, else we get problems with our laser beam skipping over objects. Alrighty, so let's think about how we're going to do this. So we're going to start with extending our script. Extend script. Oh, realizing. All right. I'm not going to care about ready. I am purely going to care about our set initial velocity because that is now something that we actually need to implement. So we get the speed of our ship right now. That is obviously not how fast we want our laser beam to travel. Now we're going to take some artistic license here. Now when you look at a laser beam, what we're going to be doing here is more accurate for a bullet. First of all, a laser beam will be traveling at the speed of light. We're going to make it go a little slower, just for the visual effect. But the other thing is, if we are going sideways with our ship, which we can be doing because the way that we've implemented our ship, when you shoot a laser beam, the speed of your ship doesn't matter. Your laser beam starts at that pinpoint and then travels in its direction, and we could ignore our base velocity here. We could just give it a velocity in the direction that we're facing and make it as fast as possible. But because of the way that space games work, the effect is really weird, especially if you're moving quite fast sideways, which you really don't notice. When you look at me just sort of flying around and doing loops around the carrier, half the time I'm actually moving upwards, so to speak, as I angle the ship down, or I go downwards as I angle the ship up, because I keep having that momentum. But you don't see that. If you shoot your laser beams, they would just disappear off the screen because you might be flying forward really fast, but you're moving down really fast. So you just doesn't feel very well when you're flying like that. While if you shoot a bullet, it travels initially at the start of your craft plus whatever velocity you give it shooting it out of the barrel. You would actually, from your perspective, it would just be traveling forward because it gets that same momentum. So we're going to do the same thing for our laser beam, even though it is not technically accurate. We're going to just pretend that it's a projectile. It's a It's a physical thing that we're shooting at. So we're going to take our base velocity and we're going to add the velocity at which we want to fire our laser beams at. So we need to decide on how fast we're going to make that thing go. Initial speed, which is going to be in units per second. And I'm going to make it something really dumb and low. This is obviously going to be something much faster, but I want to see it move away from where we are to see what it does. Because again, if we make it really fast, it'll just disappear too quickly, and we won't know whether we're doing the right thing here. That means that our initial velocity is going to be our base velocity plus our global transform. Remember that we already set this. We take our basis, we take our Z. That is the direction in which our our weapon is facing. Might be minus Z. We might get into. I might have flipped that around, but I think it's Z for forward. And we multiply that by our initial speed. So that gives us our initial velocity going forward. So that is how fast our bullet will be moving away from our craft. All right. That means that on our properties of our rigid body, and let's have a look at that. I think I've turned gravity off. Let me double check it, because I've done in a few places I've set the gravity factor to 0, but I think I turned gravity off altogether. Yeah, I've turned gravity off altogether. Perfect. So I don't have to worry about that. I just want to set our linear velocity that we start with. So I'll actually zoom that in because that's getting way too small. Linear velocity is initial velocity. So that is the speed at which our laser beam is going to move away from us. Now we're going to do a couple more things with that initial velocity. The first thing is that we're going to move our position of our projectile forward by the amount of travel that we're going to expect per frame. And that we're going to get from our so distance traveled per frame is going to be our initial velocity, and we are going to divide that by, I think it's engine iterations per second. So our iterations per second is how fast our physics process updates, and that's a constant. So unlike our render rate, our frames per second, that will fluctuate depending on how fast we're rendering. So if we're rendering too much, that frame rate will drop. When we're looking at physics, the physics engine is always going to do its iterations in its fixed steps. So we know how much we're going to be traveling in one frame by dividing our velocity by the number of iterations we do in our frame. Yeah, probably plasma ball would probably maybe I might rename that during the week, because I don't want to refactor that right now. But that's actually a good idea, just to get away from that. Not that anybody's really going to care, to be honest. You know, when you play the game, you're not even going to notice that this is what's going on. You care about that you're actually shooting at a target and it looks real, or it feels real, even though we're faking half this stuff. Okay. So what I now want to do is I want to adjust our global transform, our origin point, and I want to add half that distance that we travel. So we're actually going to move our bolt forward by half the distance that we expected to travel per frame. And I'm doing that because we're going to make our bolt the length of how fast we're traveling. And that gives us that nice good one. Will that actually... wondering if I should... Well, we'll see. Because again, if we're going faster, we might actually want to... we might want to do this for our collision shape to really Does that really matter that much? No, I think this will do quite nicely. I think this will do exactly what we want to do. Again, it's a bit of experimentation, isn't it? So, so now we know that we've positioned it halfway forward to what we're doing. So now we actually want to make sure that we have a collision shape and we show something on screen. So that's going to be our next little bit. So let's start with adding a mesh instance to this. Boom. And we're going to go and create a cube mesh for now. Yeah, we're just going to do it with a cube. I actually really want to have a plus, like a cross section of plus, because you're not even going to really see what it is, but because it's going to be very thin. We might actually make it just a little bit bigger so that we can actually see it shoot away, because when it gets very far away from us, it'll get very tiny in its cross section. But yeah, so around the z-axis, I want that to be 1, and I do that for a very specific reason. But then our cross section, I'm going to make nice and tiny. So that's going to be our little laser beam. We're going to give that thing a material. Nope, I don't want to make that a shader material. I just want to make that a normal spatial material. We're going to make this thing... actually, I'm going to leave that. Are we going to leave that right? I don't know. Let's have a look. Because I want to make that a nice... Yeah, there we go. A nice emissive material. Multiply? No. Add. Because that's we're multiplying with the texture. That's what that means. Now the big question is, do we leave that? No, we're going to make that. We do need to give it a color. That's something that I noticed, that the emissive material isn't working properly if we don't give it a color. But obviously I don't want to add it too much. I'm probably going to get a little bit of white in there, just to get a little bit like that. Because that will give it a little bit of definition and not make it look like one solid color. Again, this thing is going to fly so fast we're not even going to see the shape. So that's why I'm just turning it into a box. Now, the reason why I made the Z1 is that we can now scale this depending on how big we want it to be. It's tempting to actually change the size of the mesh itself, but you have to realize that whenever you change any of these properties here, that means that we're going to recreate a new mesh and we're going to upload a new mesh to the GPU. And if you do that every frame, even for something as simple as this, you are stressing out the GPU because it needs to constantly wait on that process to finish before it can actually start rendering frames. So you're going to have your GPU waiting on stuff half the time, and you're just going to waste a whole bunch of processing power. So you don't want to do that. You don't want to change meshes unnecessarily. For one little laser bolt, it's probably going to be unnoticeable. But I was actually surprised because I did this by accident for that little radar thing. I was surprised at how much frame rate drop I got by doing it that way. Even though it's only a little bit of data that we're sending to the GPU. There's just something in the flow of that data to the GPU, and the GPU needed to wait until it receives that before it can actually start rendering stuff. That just kills your frame rate. So that's something to avoid. Don't change your meshes on the fly. Create a mesh and then scale it. Because we can change the length of this thing simply by changing the scale on the z-axis. So the length that we want it to be is the distance that we travel. So what we're going to do now is we're going to say mesh instance dot. How's that going to be called? That is going to be scale. Yep, why not? Is vector 3. We're going to not scale the x and y axes. We're just going to scale the z axis. And we scale that by the length of our distance traveled. So now our laser bolt will be the length of the amount of travel that we're going to be doing. Alrighty. We need to do the same thing for the collision shape. Collision shape, we don't scale. Again, we're not sending collision shapes to the GPU. We don't have that problem there. And the update towards the physics engine is neglectable, especially seeing that we're just doing it one time. Because I'm not varying this, our speed is going to be constant until we hit something. Let's see. We're going to... I'm not going to do a box shape in this case, or am I? Yeah, I can do a box shape. 0.1, 0.11, so we just keep it the same as that. Oh, this is extends, so it's half of everything to make that fit. Do we care about the margin in this case? Not really. I don't think that matters. We might actually make this laser bolt bigger just to make sure that it actually hits something. We'll figure that out. We'll see how well it works. So that means that on our collision shape dot extends, is it extends or extends? I always forget. Extends, yep, extends is vector 3 0.5 0.5. And again, we might change that. You know what? I want to cache this because I don't like calculating. Length is, you know, it doesn't really matter too much because we're not doing this like a whole lot. But oh, len is an answer. Okay, so distance, far distance is, there we go. And then here, obviously, we want half the distance. What was I saying about it? I already forgot. So yeah, now length is, you know, well, it used to be in the old CPU days. It used to be an expensive thing to do, so you try to avoid duplicating that calculation because it's there's a square root in there. Computers don't like square roots; they're expensive to do. But I think in today's modern computers, and seeing that this only executes once every time you fire, probably doesn't matter. Habits die hard, I guess. So that should set that all up. Okay. Let's go back to our projectile and implement a little bit more here. So we are going to go and put another timer in. This is going to be called lifetime. So we don't want the, you know, when you shoot a bullet, we don't want to have it go on forever. And the same for a missile and the same for a laser bolt. We want it to reach a certain point, and when it reaches that point, it just, if it hasn't hit something by then, it just disappears. It just gets deleted. And that's something that we want to implement in our base script because that's going to be available for every type. But we do want to set that lifetime over here. Now, in this case, this is a static. This is not going to change. So we are simply going to say, let's give it a type. Var lifetime. Let's say that for now our default is that it's gonna live on for 10 seconds. It's probably way too long for a laser bolt. Hey, we gotta start somewhere. And in this case, we simply are going to is it time left? Wait time. Wait time is lifetime. Boom. Then we're going to say lifetime start so that we start timing. I could have probably set that through as a parameter. Let's see. True. Stop reaching 0. Okay. I need to turn that on, and I actually need to turn that on our weapon as well, on our cooldown timer, because we're going to start it. It's not supposed to be a repeating timer. We just want to, when we start it, it ends and then it finishes. So same for here, our lifetime, and then obviously when it times out, boom, and all we're going to do here is a queue free. And the moment that we queue free it, that's the end of our bullets. Have not hit anything, so it's going to disappear from my scene. It will automatically be removed from my scene tree, and bye bye laser bolt. We're not going to worry about hitting anything yet. Let's go and see if our laser bolt actually shoots. Be surprised if this works in one go, but let's see how good we make this. I really need to make an auto thing. All right, so I do want to go and fly out of our hangar just for now. All right, I'm gonna go stop. We're just gonna first see if we can shoot Okay, well, it's not working yet, so we're definitely doing something wrong. So let's go and debug this, shall we? Let's go and have a look, and we're actually gonna go. Oh, yeah. Okay. One of the things that we're going to eventually be doing is we're going to extend our weapon script to a laser weapon and all these different weapons, so we don't have to set this on each individual one. Actually, we'll do that right away. Why won't we do that right away? So we're going to create a new inherited scene from weapon. That's going to call laser. Boom. We're going to save that. We're going to call that laser, because what we forgot to do is actually assign our projectile script. So, boom, 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 boom. Where are we? Models, weapons, and it's going to be a laser scene. So now we're going to shoot our laser out of there. Cool. All right. There we go. We're going to save that. We're going back to our fighter, and now we're going to do a little trick because I don't want to reposition this thing. We're going to go and find our laser script. We're going to make that as a child of our gun. I'm going to move that as a normal node, and now we're going to delete our gun node. Boom. So now every time that we add a laser to our scene, we automatically get the projectile set up correctly. And obviously we're not going to play around with any of the other settings. So let's see if that solves our problem. I'm just gonna leave my headset lying there because we're just gonna be looking forward. All right, well, there's something more missing. Okay. What are we missing now? Let's go and just, let's see. Let's put a breakpoint here and see if we're actually getting into our fire logic. Let's start with that. I'm not going to bother flying outside. Let's see if, okay, that already doesn't work. Cool. Action press action. Action is set to primary fire. Let's actually see if we get here. So log test. I don't want to do that with a breakpoint because we break straight out of it. Sorry, I've been working with JavaScript all day. Of course, it's console.log in JavaScript. Okay, so we should be seeing a whole bunch of. Where are we getting? Oh yeah, that's that CPU particles not found. As I said, the first time that we call that thing, we're going to get that. All right, so we're never getting here, so we're missing one of these things. All right, so let's go through what they could be. That's actually we are going to go and put a breakpoint there and just see what it is. So that's going to immediately hit it, unless that is our problem. Boom. All right, so enable is true, can fire is true, projectile is null. All right, well, it's not supposed to be. So we have our laser, our projectile is set on our laser scene. Why is that not set here? Projectile packed scene. Projectile is set to our laser scene. On our fighter, we change that to laser. So let's go and close a bunch of things and see if we might be having an issue with things not being cached properly. Sometimes that goes wrong. It does help from time to time to just reload things into memory and make sure that we're not stuck with something. So here's our plane. Very good. In our plane is our laser. We have our projectile there. We have our we don't have a projectile here. Okay. That's weird. Oops. Let's set that again. Oh. I set the projectile to the weapon instead of the projectile to the laser beam, the projectile that we're going to be shooting. Okay. That's now good. Oops. Obviously, I'm not sure if there's actually a way to set up our export here to tell it what type of scene we are able to accept. I'm not sure if there's a way to do that. Would be really cool, because then it would have told us, hey, you can't use that scene. That's not a extended class from our projectile. We can see a whole bunch of tests in our output. Probably want to take that out. Boom, and we hit there, so that's running. Continue. There we go. We have a very, very, very slow, tiny projectile going out. So I just want to get rid of that test before things start complaining about that. And now we're going to do a real test and see if we can get some. All right. 1 second. I always forget to maximize this thing. There we go. Alrighty. So let's do a test at standing still first. We're not moving. So there we can see. Oh, look at that. I wonder why it's shooting a whole bunch of them. Because I'm not holding my... Oh, look at that. That's really going bad. I think we got too many of them going. Alright, something's going really fishy here. There we go. We're going back. So, why is it... I think... we probably had a lot more projectiles there than just the ones that we could see. I think there was a whole bunch of them. Because the thing that we forgot to do is can fire is false and cooldown start. We didn't actually use our cooldown. So that was probably shooting 90 projectiles a second right there. Oops. Alrighty. Let's see if this works better now and doesn't destroy our frame rates. Alright, there we go. Boom. Okay, there we go. Let's go and hold this. Boom, boom. Look at that. We got a whole bunch of them. Alright, so now I just want to go. Well, they're very slow, so we can catch up to our bullets. And I want to go. Ooh. That wasn't really what I had in mind. But you can see that our bullets are... Oh, we can keep up with them. So yeah. So obviously we're still accelerating. And we're catching up on our bullets while we accelerate. That is hilarious. Alright, the other thing that we can see is that they are getting a rotation, I guess. But, hey. That's what we get for having really slow moving bullets, right? Or laser beams. So let's go and give these guys a bit of a proper speed. So let's go back to our laser beam. Let's make them go a whole lot faster. That might be too fast. We will see. They should be a lot longer now when we shoot them as well. All right. Boom. Careful. Wait. Always forget maximizing. There we go. Boom. All right. There we go. That's a bit more cooler. So yeah, we're shooting now. Now, one thing that is interesting is because they're... I should have a target reticle at some point. But yeah, we are shooting our laser. I think that's actually a kind of a nice speed to shoot them at. I'm not against that. I'm a terrible shot, but all right. So Now that is, of course, really not something that lasers should be doing, but a bullet should be able to do that, but not lasers. But it does prove our collisions are working. We can shoot our enemies. All right. So now we actually need these things to do something. I think first things first, going back to our projectile scripts. I'm going to half that for now. That might even still be... No, actually, let's go. So at 500 units per second, after 2 seconds, we've gone 2 kilometers, which is our radar range. So basically, we've made our projectiles not be able to extend our radar range. That's already when these things are, you know, when your target that you're shooting at is far enough away. We might up that lifetime at some point. Obviously, for lasers, that's our default. Once we have missiles, lifetime for a missile is probably, you know, 10, 20, 30 seconds at the very least, or it's never going to hit something. But I think that's a default setting that we want to set for now. Alrighty. Now the other thing that we want to do, and this is something that we are going to set on our projectile. So in this case, we need to go back to our models, weapons, laser ENC. There's one thing that we're going to change here. Is I'm going to change the mass of this to 001. Now, I don't actually care about mass. I have not been looking at changing the mass of anything. So all my fighter ships, my player ship, my friendly ships, and my enemy ships, they are all 1 kilogram. Very, very lightweight little guys. While my my carrier is the maximum, which is 65,000 kilograms, I think. Which for a carrier is still very little. But relative speaking, which is the only thing that we care about, you know, make sure that if one of my ships flies into the carrier is going to be pretty much unaffected, right? I've turned it into a rigid body because eventually I want to be able to have the carrier fly around or do stuff instead of it what it was before, a static body, which means that it's of course always fixed in place and it has an infinite mass basically. But we want to make sure that the tiny fighter ships, if they bump into the carrier is really unaffected. We're not going to push the carrier away. We're going to bounce off this thing, and eventually we're going to take damage when we do that, because obviously that's not a very smart thing to do. If the fighters hit each other, as long as they're similar in weight, they will react the way that you expect them to react if you hit them. And because we've got our inertia and everything like that, really in space, we don't have gravity, we don't have anything like that. We purely have our inertia being controlled by our linear damping. That doesn't matter, that doesn't care about the weight of the object either. So as long as we have some relative weight, we're good. We want to make our laser beam very, very light. We might even make that even lower, although it doesn't really matter that much. I'm going to make that really, really light so that when we next shoot our things against our enemy ships, they don't go and fly off like crazy. We might do that eventually with things like projectiles, in the sense of like from a railgun or something like that, because obviously you if your ship gets hit by something physical, it will have some effect to your ship, especially when they're traveling really, really, really fast. And that could, you could use your guns then to knock someone, of course. And for ourselves as well, once we get hit, we might be knocked, of course, as well. So, so yeah, those are things that we're going to be looking into. With missiles, once we implement those, they are going to explode, and that's obviously we're going to actually add a extra force onto the thing that they explode against. Ooh, we're starting to run out of time, so I think we're just gonna finish the laser beams today. Make sure that they can hit our ship and actually make sure that our fighters get some damage, and I'll probably start working on some shield effects and stuff like that during the week. I want to keep the missiles then for next week, because we're going to continue on this work to implement missiles, but obviously missiles don't fly straight. We need to do our first bit of AI for implementing our missiles, and it's already 12 p.m. so we don't have enough time to make that happen tonight. Let's see if we can at least get our laser beams to do some damage to our fighters, our enemy fighters, and yeah, go from there. So, okie doke. So we got our mass lower. That's good. We now need to make sure that we are going to go and turn our contact monitor on, because else we don't get signals when we hit something. And we only need one contact. We're only going to check for hitting one thing at a time. Okay. That means that now in our node, we're going to say body entered. That means that we've hit something. Whoops. And we're going to go and no, we're not going to connect that up here. Okay. This is what you get for not paying attention, Baz. So let's go and disconnect that. Let's go and turn it off, because obviously that is something we want to go and implement on our base script, because that is going to be the same for everything. Whether we are missile or bullet or laser, we want to know when we hit something, and we want to be told. So, boom, body entered. There we go. Now, oops. One of the things that is really nice is, because of our mask, we know that when we fire things, or when our wingmen fire or something, it's only going to hit enemy ships. And when enemies shoot at us, they're only going to be hitting us. We might allow friendly fire at some point in time. We'll see. But the bottom line is, on projectile body entered is only going to be triggered if we actually hit a proper ship. Now, we probably are going to add the asteroids in here at some point, because right now we can shoot straight through an asteroid and hit the ship behind the asteroid. That would be cheating. We can do that, so that's something that we might have to deal with in the long run, and say, hey, if the body is an asteroid, just destroy the laser bolt. We're done. If the thing that we hit is an enemy ship, then obviously we damage the enemy ship. All right. So, the first thing that we need to do is specify how much damage this thing does. And again, we're going to set that up for our in our base script, and then we're going to tweak that for every type of projectile that we implement, be it a laser beam, be it a God knows what, a missile, whatever. For now, we're just going to add a single damage indicator. But we might eventually split that, like we could do different levels of damage to shields as we do to a enemy ship itself, so that we could have weapons that are very good at taking down shields, but not very good at actually damaging the enemy ship itself. And we could have weapons that are horrible against shields, just get stopped by shields, but that do great damage to a ship. So you could think that a laser beam might do a lot of damage to shields, while a bullet might be absorbed by a shield. The same with missiles. Some missiles might just explode against a shield and not do any damage to the ship, and only do minor damage to a shield, while they would do a lot of damage if they hit an unshielded target. Not going to worry about that right now. So we're just going to say export float var damage given is, and we're just going to call that 1 for now. And we might make it higher or something different, or whatever. And again, we might split that between energy damage and normal damage at some point in time. For now, that's all that we're going to do. All right. So here is one thing that that we worked on last time, and that I think I'm going to need to improve a bit on, is we do have our enemy script that is the base for all enemies. But when we're looking at health and damage and all that sort of stuff, that should really be a single implementation for enemy ships, for friendly ships, and even for our player ship. Although our player ship is going to be a little bit more difficult because of the fact that it has a totally different extents tree. So for now, I'm going to implement this all on our enemy script only, but I'm probably going to move that into something that I'm going to have the enemy scripts and the friendly scripts all inherit from, and then it's only the AI logic that's going to be different at some point in time. So that's probably going to be an improvement in this logic at some point in time. But for now, because we're only shooting our enemy ships, I'm not too worried about it. So, first things first, export var is max health. So we're going to give our ship a maximum health that it has, which also means that we're going to have an onReady var for current health, which we default to our max health. So when our ship spawns, when they start at maximum health. Now, that also means that we're going to have a max shield. So let's say that the max shield is also by default 100. That obviously means that we're going to have a shield here, which is going to default to max shield. So again, we're going to take down the shield first as we hit it, and then when the shield is down, we're going to take health. Right now, we are not going to care about individual parts of the ships. We're not going to care about what side of the shield we're hitting. That's what you see with a lot of these type of games, is that we have actually a separate shield for the back, a separate shield for the sides, etc., etc. For now, we're going to keep it nice and simple. We just have a single shield. When the shield takes damage, the shield decreases in damage, and once it's 0, that's the end of the shield. So that's really where we're just going to what we're going to start with. Now, I don't have a shield effect in this yet, so that's again one of those things that we're going to do something later on. We're also not going to worry about shield regeneration at this point in time. It's just whenever the shield is gone, the shield is gone. Boom! Whenever the health is gone, health is gone. That does remind me. We're going to worry about that later. So we're gonna take a function here. So take damage. What did we call that in our projectile? Damage given. Okay, so damage given is floats. Boom. So here we're going to say if shield bigger than 0. So if we still have shields, we are going to say shield is shield take away damage given. And obviously, we want to make sure. Can I do that with a max function? I don't know. We can. We want to make sure that it never goes below 0. Now, if we break our shield, we might want to carry over the damage onto the health of the ship. But for now, we're just going to ignore that. We're just going to say, hey, if our shield goes to 0, then, you know, if you, let's say that we do 10 damage and you have 5 shield left, you lose 5 damage points. I'm just going to say that our shield absorbs any leftover damage. And we might change that at some point in time, but for now we do that way. If shield is 0, I'm just going to pass for now. So one of the things that I also want to add, which we don't have time for tonight, I also need to do some searching around the internet, is obviously when we hit the shield and we still have shield left, first of all, we will do some sort of animation at some point in time. So that's something that I'm going to be working on soon. So we're going to make the shield visible. For now, that's not yet the case. But we might do some sounds, right? If you hit the shield and the shield doesn't break, we play one sound. If the shield breaks, we might play a sound that you can hear the shield break. etc. etc. I might play then a different sound when we actually hit the an unshielded ship. So in this case, we're going to say health is, again, we don't really care. In this case, we could make it negative, and because we're going to blow up the ship anyway. Health minus damage given. Again, I might end up splitting damage into shield damage and health damage. And we might eventually apply some factors here that, although I think the strength of the shield and the max health of a ship is enough to worry about that. Anyway, if we reach 0, we're going to go and blow up our ship. Now again, we're running out of time. This is where I wanted to actually use particles for, but we'll have to move that to next time, or maybe that's something that I'll work on during the week. Obviously right now what we want to do is actually destroy our ship and blow it up. For now, we're just going to Q free it just to make it disappear. When we damage it enough, we're just going to poof it out of existence. But in the long run, we're going to be doing more with that. We're probably still going to Q free this thing, but we're going to put a new object in place, which is just going to be a ship animating, breaking up, and an explosion, something like that. So that is what we need to do there. Okie dokie. Let's go and see whether we can blow. Actually, before we do that, I want to go and up this a little bit, because else we're going to shoot it like we have to shoot it 200 times before something happens. Because again, we don't have any of the sound effects, we don't have any of the visual effects when we hit something. We just have the hopefully we have the bullets disappearing on us when we hit something. So let's go and fly again to our enemies. They are not going to fly away from us, so it's going to be easy to hit them, hopefully. Although a terrible shot. There we go. Maybe I should move them a little bit closer for next time when we test. So I don't have to fly out for half an hour before we get to these guys. Here we go. Oh, keep missing him. So, now the interesting thing is, I think we hit it a lot more than the 20 times that we should have hit it. Plus that we can see that our bullets are bouncing off of him, which is a really cool effect. The fact that our bullets are bouncing off of him means that our bullets are not detecting that they are hitting our enemy craft. So, we know that the collision masks are correct, or else we wouldn't be hitting. We know that our collision shapes are therefore correct. We're just not getting the hits that we're expecting. So, now obviously we were making some changes here. So, that's our laser object. So let's go and close that. We don't care about you anymore. So here's our projectile. We've got our contact monitor on. That's the most important one. We got contact reported set to 1. So that means that we did that. So contact monitor, rigid body will emit signals when it collides with another rigid body. We've got body entered. We got our... Might help if we actually implement that. Oops. So, where's our enemy script? Take damage. Body.take damage. Again, I'm not going to check whether that method exists, because right now we know it exists, because we're only getting hits on that. So we have to tell it how much damage we're going to give it, and then we're going to Q free our laser bolt. All right, let's see if we've done the right thing this time. All right, boom. There we go. Let's go. Still haven't moved the enemy ships closer to our ships, but we'll get there. Yeah, I definitely have to move them closer. Here we go. We got you. Ooh. That's not good. What are you unhappy about? Okay. That's interesting. Why is that happening? Okie doke. That is because let's have a look at our player scripts. No, that's our player itself. We need to look at our plane scripts. Our plane is able to collide with projectiles. So this is an interesting thing when we're looking at the way that collisions work. Is when I have object A, and I say that object A is in layer 4, and now I have object B here, and I say this object can hit things in layer 4, so its mask is set to layer 4. Then when this guy hits that guy, this guy triggers the collision. But both of them get the collision reported. So the fact that I have made my plane detect that it collides with the bullet, even though I've told my bullet that I can only collide with enemy ships, it's still colliding with my plane because my plane is colliding with it. Which I think is actually a bit of a nuisance. I would actually have liked that to be a one-way street, that the object that has the mask set is the object that gets the message. So in this case, it would only be my bullet getting a message only when it has its mask set, and not that both of them get it. So I think that's actually a bit of a nuisance, and it also means that now that I put projectiles off on this thing, on my my player planes, that means that now I should no longer get that collision. But if I have a projectile shot by my enemy ship, and that hits my plane, then even though that on the plane the mask is turned off, now my enemy bullet gets a signal I've hit the plane, and my plane gets a signal I've been hit by the bullet. The other side of that story is that we could also flip this whole thing around and say that it is actually the object being hit getting the signal I've been hit by something, and then querying that thing to say, how much damage have you done to me? But I actually think that the other way around makes more sense. I think the bullet is hitting something, it detects that it's hitting something, and it then does damage to that thing that it hits. So I'm okay with turning that layer off here. But it does mean that obviously if we are ever implementing a function here to react to our plane being hit, so if we have on a node we implement our body entered, we have to be aware that our projectiles can actually hit our ship. Our enemy projectiles can hit our ship and therefore trigger our body entered, even though we haven't turned that mask on. Like I said, I think that's annoying. I don't actually like that behavior. That also means that when we look at our enemy scene, we need to do the same check. And here we go. We don't want this whole thing to be on. So we're basically gonna go and turn those things off. So we can hit the player, we can hit friendlies, we can hit enemies, we can hit the asteroid. Those things we all want to be reacting on, but we don't want to react on projectiles. Because again, we want the projectiles to drive that. And then last but not least, we want to do the same thing on our friendly script. Again, this is where it's going to be probably really a good idea to have one root script here that dictates this behavior. I'm going to turn those off so that we know that we need to turn those on if we want to do something with that. So let's see if our theory is correct and if it works now. Yep. I still haven't moved our enemy ships closer. I keep forgetting. I think I also need to increase the range of our radar, because I could already see them, especially now that they've got their tails. Okay, so our conclusion was not correct. What are we hitting now? Okay, so I'm going to guess. Alright, that sucks. What did we miss? So I'm actually going to guess that now that we've changed that on our plane, we are probably overriding it on the fighter plane itself. Where's my player scripts? Here we go. So we're doing this one. Collision? No. Why is it still colliding? That is weird. What are we missing here? So it's in our projectiles. We've put our layer by default on enemies. Okay, let's go and take a look at our laser scene. We have our collision mask set to projectiles. That's really weird, because that means that it should not even hit anything, because that should default to 3, which we're also going to change. Oh, there we go. So 4 is the bit for mask number 3. So how does it still hit it when our collision mask is set as such? That is weird. Okay. So that's the weapon script. Collision mask is set up to collision mask. We add our child. Let's do a print. All right. Here we go. Boom. Did it put anything in our log? Because that was really right away. Mask 4, which is what we expect. So why do we still get our projectile body entered on our rigid body plane? So let's go and have a look. Self. Rigid body 1804, that's our self. Okay. Our mask is enemies. Bit 2, value 4. We are in our projectiles. And the one that we're hitting is our body. Our collision mask is wrong. Why is the collision mask set like this? Okay, well, we found our problem. I'm not completely sure why. So let's go and have a look if something got... Ah, look at that. There's our problem. So our mask was at some point set on our main scene. Probably because that's where we started. I think that's probably because we started with the interceptor. You know, the cockpit that we had without the plane, and then we switched it over to the plane. And it must have remembered that mask. So let's go and have a look at our things here. So here's the same problem. All these guys are... They have overruled collision shapes here. Refresh. There we go. Look at that. They're all wrong. Oh. That, of course, you know, once we're really a lot further in our game and we actually spawn these things in instead of having them fixed into our scene, that would eventually fix itself. Why? Oh, haha. These are our enemies. This time I did not forget to move them closer. Don't want to put them too close. All right, let's have a look. Whee! We can shoot. I'm not going to worry about the output to our logs. Whoa. My cable got stuck. Alright, so as soon as my... the reason that jump happens, by the way, is because I've got this on my chair and it's out of range of my sensors. So the moment that my lighthouse figures out where this thing is, all of a sudden my position changes and I'm outside of my ship. Again, one of the things that we need to do very soon is actually do a fade to black or something like that whenever we're outside of our cockpit, because obviously we don't want the player to be outside of our cockpit. So yeah, that's something to add in pretty soon. All right, where are you? There you are. Okay, and he's gone. We killed him. See if we can kill this guy. And he's gone. So now we can also see that as we hit our enemy ships, the bullets stop traveling. So we're firing our lasers. Lasers are hitting our enemy ships. And after they hit them enough times, they disappear. I call that a successful result. There's a lot of stuff left to do. We want to have a shield effect. When the laser bolts hit the shield and the shield take damage, we want to see something happening on that shield. We want to have an effect that we see the shield flickering. When the shields fail, we want to do something with that. When we start damaging the ships, we want to probably see some effects that the bullets are having, you know, on the enemy ship. And we might even make that a return value of the take damage function, whether we are hitting shields or whether we are hitting the ship, so that we can react accordingly to that. Because again, we want to do, very likely we want to have different effects for when a missile hits a ship or when a bullet hits a ship. So like with the lasers, when they hit the shield, we just want them to disappear and a shield effect. When they hit the craft, we might want to have little little particle effects as they hit the ship, so we can really see what we're doing. We might want to do more things depending on the health of the enemy ship. You know, once let's say that the enemy ship is below 50 points of health, we want to start seeing a smoke trail or something like that. So there's a lot of room for the improvement. The other thing that is going to be very important is that we're going to get feedback of the health of the ship in our selected target screen. So now that we have a health indicator of our enemy ship, and that's going to be part of our the script that we keep extending, we will know that whatever we got selected has that information, because we're obviously also going to add that to our friendly ships. And we'll be able to display that. We'll be able to show a health bar or a shield bar or something like that. And again, right now we're just going to have a single health setting and a single shield setting. We may improve that in due time and actually have health of different components of the ships, especially once we start shooting at capital ships. We might want to have different parts of them take damage. That's all to come. That's all stuff that we're going to start looking into. I'll probably be spending some time this week on that, especially on probably adding a shield effect in there, because next week during the live stream I want to concentrate on the missiles. I was hoping that we would get to that tonight, but unfortunately we ran out of time. But the missiles are going to be really interesting because they are going to be the first bit of AI that we're going to add into our game. Because obviously, while we could have a dummy missile that just flies on straight, I don't really think they are, who's going to have those in space? You're never going to hit something with those. Maybe at some point a torpedo to hit a capital ship because they are slow. They won't suddenly turn or evade. That's the only thing that I can think of makes sense. Everything else is going to be either heat-seeking missiles or radar-based missiles or something like that, which of course they're just different variations of how the AI works. There's no real radar involved. There's no real infrared involved. It's all going to be trickery. So yeah, that's the first bit of AI that we're going to be building next week. Is having a missile that that can actually home in on one of our enemy ships, and we start playing around with how we're going to set settings to restrict it and to make sure that that makes sense. So yeah, alrighty. I think that's where we're going to leave it off tonight. If there's any questions or any remarks, I'll stay online for a minute or two more, see what comes in. But yeah, I think it is late enough. I need to go to bed. What can we do while we wait for some questions? So yeah, so when we look at this guy, and I actually want to see this side here. Oh, I forget the key combination for this. No, that's the one. Let it fly. Oh, problem. So yeah. So we're going to go and look at having some information about the selected ship here, maybe a health bar here or something like that, so that we can actually have an idea of how much health the ship that we're shooting at has. The other thing that we also need to look at is regenerating shields. So again, that's going to become dependent on where our power is going to. Again, for us, we're going to control that in our ship. It's going to be something that we control on keyboards, but it means that all the enemy ships and the your wingman and other players are going to have the same mechanics. It's just going to be controlled by an AI. It's going to be important, and we might play around with a defensive AI will with all their power toward the shields. The moment that the shields start to get low, an offensive AI might still keep the power on their guns or on their engine, and therefore those sort of ships you'll be able to take down their shields much more quickly. But they'll be more aggressive as well, so they'll be harder to hit. Those are the sort of things that we're going to start playing with once we start building the AI for the enemy ships. So, but I think missiles are a really nice start for the AI, because missiles are really straightforward. They just want to steer towards the target that they have, and the things that we need to add in there is what is their view? How narrow can they still detect if they're on course? How fast can they turn? How fast are they accelerating? All that sort of stuff. It's going to be fun. And infrared missiles, they will be efficient if they are targeting the rear of an enemy ship, while if they see the front of the enemy ship, the exhaust will be hidden for them, so they'll be less accurate. So we need to simulate that. While a radar-based missile will always keep homing in on the enemy ship, things like that. So, so yeah, it's going to be fun implementing that, and it's actually surprisingly easy to do that logic. It's you can get some really complex behavior for something like a simple missile by doing some really basic things, some really basic checks. So, hiya, Akadeen. I glad that you think it's woe. All right. Well, seeing that there aren't any questions coming into the chat, I'm going to leave it here. So again, thank you all for watching. I hope you guys come around again next week. Yeah, as who was it who mentioned it? Was it Soundbeats who said, maybe we should do a little bit more advertising on when these streams are on. If you guys want to spread the word, I'd be very appreciative. I might flag it a few more times, either in the Godot IRC or something like that, or the Godot Discord. I don't really like pushing that too much. The same if I did a single post on Facebook to let everybody know that I'm streaming, but I don't really want to flood that channel with those sorts of messages. I don't really think people will appreciate that very much. So, any help from you guys if you want to tell other Godot developers that you know? So far, 10 o'clock for me, sitting time in Australia seems to be something that I can keep up. I might change that at some point in time just to see if another night of streaming might mean that more people can join in. Though I still need to see what works for me. In the weekend, I tend to try and go out with the kids and turn in relatively early. So the other option might be streaming on a morning, maybe on a Saturday morning, so that people can watch Friday nights. Although I'm assuming that people will be going out for drinks once the pandemic is over on Friday nights. Whether that's a good time for them, who knows? I don't know. Suggestions are welcome. So. All right. So I wish everybody a good night, and again, thanks for watching, and until next week. One last thing. I am working on some new tutorials. I am doing a tutorial on what are they called? Imposters. So one of the things that I'm looking at for this game, when we look at the asteroids, is you could use billboards as a lowest level of detail, but one step up from billboards is an imposters, where you're actually still using a billboard, but you have different images depending on the angle at which you look at the billboard, so that it doesn't look like you've got it's less obvious that it's just a square with a texture on it. So that's something that I'm working on. And the other thing, of course, is my next part of my weapons tutorial, which I've prepared most of it, but I just need to record the actual video. So that's going to be about the two-handed holding of a gun to stabilize it. And after that, I plan to come back at the object interaction and looking at stuff like opening doors and stuff like that. So I know that I'm concentrating on my space game at the moment, but I'm not forgetting about my tutorials, so watch out for those. Hopefully I'll have one out in 2 or 3 weeks, closer to the 2 weeks than the 3 weeks, I hope. It depends a little bit on how busy it is at work. So yeah, that's multiplayer VR. Okay, one last thing before I really call it a night. I want to make a simple multiplayer mode in this thing just for fun. I'm not sure if for me, I find it more important for a game like this. There are a bunch of multiplayer experiences out there for space sims. They get boring really quick, in my opinion. So I'm planning to make a campaign-based game, a single-player campaign. That's going to be the main mode of this game. But I think it would be very fun, especially when we're still in this stage, when we don't have campaigns yet, and we don't have any complex enemy AI. Adding a multiplayer implementation using the multiplayer functionality that's built into Godot would be a nice topic for a stream at some point in time. And it probably will take 2 or 3 nights to build it. But that could be a fun thing to do. So I definitely have that on my list of things that I want to tackle with this project. So it is something that I'm going to look at. But it's going to be very straightforward and simple. It's not going to be very, it's not going to be something that you can have, a 64-player arena with planes fighting with each other. It'll probably be, 4 planes on the land or something like that. So that is something that I want to look at some point in time once we've got a little bit more stuff working. Alrighty, that is really it for tonight, guys. Thank you again for watching, and see you guys next time.